Assalamu alaikum. Hello, everyone. We continue our lectures. We have reached the last topic in our series of lectures, the topic of clustering methods. Clustering is actually under the umbrella of unsupervised learning because actually in the problem of clustering, we don't have class labels. The objective or the goal here is to actually reveal the underlying structure of the data and define if there are different clusters and associate different points to their clusters, as we will see as we proceed. So there are two types of clustering. There's the agglomerative type, which is a bottom to top approach. So we start like by assigning every node to its own, defining like a number of clusters that's equal to the number of points or nodes. So every point is a cluster by itself. We call it a singleton cluster. And then we start merging clusters. Eventually, we have all of the points belong to one cluster. Okay, we will get to know more about this as we proceed. The other type is divisive approach, which is top to bottom approach. It's the other way around. We start with all points being belong to the same cluster, and we start breaking that to smaller clusters. So we start with the hierarchical clustering, which is under the agglomerative type of clustering. So here are the steps or the methodology of the hierarchical clustering. Okay, here how it works. Okay, so these are the steps how we build a hierarchical clustering model. Okay, so first step, we use any computable cluster similarity measure. So we measure the similarity between two clusters, Ci and Cj, using some metric, okay, that defines our similarity between any two clusters or points. What kind of similarity you pick, that depends on your application or use case. You could use Euclidean distance, okay, which is Euclidean distance is the nearest distance between any 2 points. For example, if you take any 2 points in the two-dimensional space. So first point will be represented by x1 and y1, and second point will be represented by x2 and y2. So the Euclidean distance is actually the square root of x1 minus x2 square plus y1 minus y2 square. That's the Euclidean distance. That's the shortest distance between any 2 points, okay? That's one distance. That's one similarity metric that you can use, okay? There are many similarity metrics, as I said, and the choice of the similarity metric depends on your use case or application. Another one, for example, here we consider is the cosine similarity. So cosine similarity is used when actually you care about the angle, not the distance. Let me explain this here. So any 2 points in this vector, they have very high similarity, okay? Because cosine of the angle between them, is equal to 0, so cosine of 0 is equal to 1. So they have very high similarity, okay? Compare that with this here. If I have point in like in this line and point in this line, so the angle between these two lines is equal to 90 degree, okay? So cosine of 90 is equal to 0. So the similarity is at very low here. These are two perpendicular lines, while any 2 points here or any 2 points here, no matter how far they are, they still have a similarity of 1. So if I have a point here, for example, let me do it this way here. This is the pointer. Okay. So if I have a point here, okay, and point here, they are very close to each other in terms of distance, okay? But their similarity, if we are using cosine similarity, their cosine similarity is equal to 0, okay? While compare like that with like the similarity between this point and another point that is here. So these 2 points, they are very far away in terms of the distance, compare it with the distance between these two, but they both are in the same direction, okay? So if we are using cosine similarity, then the cosine similarity between these two would be equal to 1. So they are very similar to each other, okay? So as I said, the similarity metric you choose depends on your use case or application, okay? Let me go back to our slides. Okay, so I think for the rest of this uh, topic, we will mainly be relying on the Euclidean distance as a similarity measure, okay? At least the examples or the use cases we consider here, we use Euclidean distance for them. Okay, so you defined your similarity measuring metric, then you assign, like you create your singleton clusters. So every node is in a separate cluster. The ith node will be in the ith cluster. Okay, and then you enter this loop here. Okay, you identify two most similar clusters. Okay, if there is a tie, then you break that tie. For example, if there are two pairs with the same distance, then you randomly select one of them. Okay, so you define the most similar clusters, and then what you do, you actually unite them in one cluster and remove these clusters. You remove the CJ and CK. If, for example, if CJ and CK are the most similar ones, you delete them. You just create a new cluster that is the union of these two clusters. That will replace these two clusters. So these two clusters will become one cluster. And you keep repeating that, okay? So until you reach like one cluster, all of the nodes will belong to one cluster. At the first iteration, you will have actually singleton clusters. So you measure distance between points, okay? But after that, you start measuring a distance between a point and a cluster or between clusters. How you measure the distance between point and cluster or between two clusters? So what happens actually here? Okay, it's explained here, okay? So you measure the point between that node, you measure the distance between that point and every point in the cluster, okay? So you measure that, and then there are different ways. You either take the max of all distances, that will be the distance between the ith point and cluster C, or you take the min of those distances that will define the distance between node I and cluster C. Okay, we consider max and min here, but there are more choices like the average, for example. Okay, so one thing I forgot to mention here, when you are, how do you measure these distances and you define the two most similar ones? So you will measure the distance between, for the first iteration, you will measure the distance between every point and every other point. Okay, and then as you are proceeding, you will be measuring the distance between a point and the cluster. So you will measure the distance between that point and every cluster, and then like add it to the cluster that is the most that maximizes the similarity. Or if you have two clusters, the same thing. So if you have multiple clusters, if you, after a couple of iterations, you have a number of clusters, then you will measure the distance between every cluster and every other cluster, and you merge the clusters that are the most similar. Okay, I'm using the word distance here, but the word similarity is what we should use in general, because similarity could be the distance, could be something else. But how you measure the distance between any two clusters or a node and cluster, you have what defines the distance, I mean, okay? What defines the distance is like you actually take the distance between every point here and every point there, and then the distance will be, then you aggregate those distances, depends on what you use. You could use the max or the min or the average or whatever, okay? So that's the idea at very high level. You also look at the dendrogram. Okay, to that this is actually, this dendrogram visualize the sequence of the cluster merging, as we will see later on. Okay, so then you need to choose a threshold, okay, to define like where you stop, because you keep merging, okay, all the way, they all will belong to the same cluster, but somehow you need to put a threshold in the maximum distance, and then that threshold will actually define what is how many clusters you return as outcome of your model. Okay, that depends on the threshold you choose. It will become more clear when we come to an example later on. What do we mean by a threshold? Because these two can actually be explained better as we look at the example. Okay. Now let's look at this figure here and like see, like go see how these steps work, okay? Visually, okay? Now, if we start, okay, before we start, let me ask you a question. So now if we start here, what are like which 2 points will be like will form the first cluster here? Okay. So we are using the Euclidean distance. If you look here, you will find like point 14 and 15 are the closest to each other. So they will form the first cluster. Okay. Let's look at the video together and follow the steps here. So 14 and 15 will be the first two to combine in one cluster, as we can see here. Then maybe 4 and 5. Yes, after that, the distance is a little bit higher. This is going higher in terms of the uh, uh, height here. Okay, then 6 and 10, then 2 is close to 4 and 5. As we proceed, we're merging more and more nodes, okay? Eventually, they will all belong to the same cluster. We will have one cluster, but I can choose a threshold anywhere, and that will define how many clusters I will return. For example, if I choose my threshold to be here, because this height represents the distance, as we will see later, it will become more clear. So if I cut here, okay, then I'm crossing these three lines, then there will be three clusters. This is the first cluster, this is the second cluster, and this is the third one, which are this, and this, which seems to be the most reasonable choice. If I cut here, I'm crossing two lines, then there will be two clusters. This is one cluster, and this is the second cluster. Things will become more clear as we will see, with this example, actually. So here, as we take this example, we have 5 points, okay? So this matrix is actually, we're using the Euclidean distance here. So as a similarity measure. So this matrix represents, every element here represents the distance between the corresponding 2 points. For example, this value here, 8, that means the distance between point 1 and point 2 is equal to 8, okay? And so on. So the diagonal elements are zeros because the distance between a point and itself is equal to 0, okay? So now this is the distance matrix. So now if you want to perform hierarchical clustering, then which are the first 2 points that we will merge in one cluster at the first iteration? Look here, the ones that have the minimum distance, right? So which are point 3 and 5, right? So, and by the way, this is a symmetric matrix because the distance between point 2 and 1 will be equal to point 1 and 2, right? So it's the same. So here, point 1 to 2 is equal to 8, point 2 to point 1 is equal to 8. So point 3 to point 5, the distance is equal to 2. So then we will merge point 3 and point 5 in one cluster, okay? And then we will measure the distance between every node with this cluster and every node with every other node or point. So now how do we measure the distance between point 1 and the cluster that is defined by these 2 points, 3 and 5? So here we are using the max, okay? So we will measure the distance between point 1 and 3 and point 1 and 5, and we will take the max of these two, which is equal to 13. If you look here, point 1 to 3 is equal to 3. That's the distance between point 1 and point 3. But the distance between point 1 and point 5 is equal to 13. So the max of these two is equal to 13. So that's why the distance between point 1 and this cluster that is defined by the 2 points 3 and 5 is equal to 13. So here we have chosen to use the max, okay? As I said, so which one you choose, that depends on what you want to achieve, okay? Or what is your use case or application, okay? So here we're using the max, okay? Now we measured also the distance between point 2 and point 3 and this cluster that is defined by points 3 and 5. So we will have all the distances written here. You just need to go back here and look at the distances, okay? And if you are measuring a distance between the point and the cluster, you will measure the distance between that point and every point in that cluster, and then you take the max. So we ended up having this matrix here. So now, which points we will merge in a cluster, okay? So if you look at this here, there's a tie here. Okay, so there are two choices that achieve the minimum distance. So 0.4 with 0.1 and 0.4 with 0.2. So we will break that tie. We will choose one of them. So here we have chosen to combine 1 and 4 in one cluster. Okay, so we'll have 1 and 4 here. Okay, and we have 3 and 5. So we will do the same thing here. How do we measure the distance between two clusters? As I said, we will look at the distance between the first point and the first point here, second point with first here, second with second, and then we will retrieve the maximum. Okay, and the maximum is 13 here. Okay, so then doing so we get yeah. So that's now which ones we merge. If you look here, we will merge 0.2. If you look at here, so the minimum distance is between 0.2 and cluster 1, 4. So we will merge these in one cluster and we proceed the same way. Okay, so let's look at the dendrogram here. This is the dendrogram. We started with 3 and 5. The distance was 2. So the height, this height here represents the distance. The distance was 2. And then 1 and 4, the distance between 1 and 4 was what? If you look at, where is 1 and 4 here? Was 5. Okay, so the distance between these two is at 5. And the distance between 0.2 and this cluster that is defined by these 2 points, 1 and 4, it was around 8, if I remember correctly. Yeah, this is 8. Okay, and then finally the distance between this cluster and this cluster, which was 13. Okay, so that's it. So the height here is 13. Now if I choose my threshold to be 10, I will cut at this level. And if I cut at this level, then there are two clusters. Okay, this is the first cluster that contains the points 3 and 5, and this is the second cluster that contains the points P1, P2, and P4. Okay, if I cut here, if I choose my threshold to be 6, okay, then I will go through these 3 lines. I will cross these 3 lines. So then we will have 3 clusters. The first cluster is this one that contains the points P3 and P5. The second cluster is this one, which contains the point P2. And the third cluster is this one, which contains the points P1 and P4. Okay, let me stop here for today. We will continue with the Python implementation of that next time. Thanks for watching and see you next time. Assalamu alaikum.